Well, good evening. This is the sixth and final webinar in the series sponsored by Bruce Power and RBC. The other 5 webinars were on topics on water quality, species at risk, invasive species, plastic pollution, and coastal processes. And just a note for those people that are interested, all these will be posted on the Coastal Center's website. So welcome to Climate Changes, with apologies to David Bowie. If you're wondering, we're broadcasting from the research vessel in the center of Lake Huron. With me, I've got Captain Aaron Laurie and second mate Mitch and third mate Kate. And if you're really interested in where we're broadcasting from, you have to wait till the end of the broadcast. I'm Pat Donnelly. I'll be your host. Be your host this evening and lead you through about a 45-minute webinar on the topic of climate change. Lots has been in the news recently. Climate emergency, Fridays for Future, Greta Thunberg, Extinction Rebellion. So certainly this is top of mind for many people. The material that we're talking about tonight are based on work last year from the Environmental Law and Policy Center. Also our own data from our Coastal Action Plan, which is in progress, and also graphics from a previous climate change education kit that the Coastal Center prepared. The original intent of these webinars was to provide training and information to our volunteer base of coastal watchers who monitor the shoreline and provide regular observations. However, I've been advised that our audience tonight might be somewhat larger, so for that reason, we're going to start with just a few basics of climate change, then talk a little bit about what's happening now, and then what we're anticipating for the future. So a little bit of everything. What I'm hoping is that tonight you will take away some items of interest and also learn a few things. As far as key takeaway messages, these are the 4 important concepts that'll be described tonight that hopefully at the end you will take away. The difference between climate and weather, what we mean when we're talking about climate change mitigation versus adaptation, the issue of sea level rise and whether it has any effect on the Great Lakes, and the whole concept of warmer, wetter, and wilder weather events. So taking a page from the past, one of our climate change education kits, we produced these graphics, which we feel are appropriate even today. This was back in 2002 and updated in 2007, because it does give the basics with regards to climate change and what we call the greenhouse effect, or the enhanced greenhouse effect to be more accurate. The graphic on the left is the cover page, so Changing Our Future, Great Lakes Climate Change. The graphic on the right is the illustration superimposed over top of Lake Huron, showing how the sun's rays, being shortwave radiation, penetrate through the atmosphere and hit the Earth's surface, either the water or the land base. And those 2 different surfaces heat up and cool at different rates. Once they heat up, then they give off radiation, which is long wave radiation, which are the red arrows. And long wave radiation is not as able to penetrate through the atmosphere. Thus, we have those star-shaped features, which are green, representing the greenhouse gases. That is what provides us with the warming effect of the Earth, which is a normal process. Now, what's happened in recent times since Industrial Revolution is we've added more greenhouse gases to the air, which are shown in these graphics. So on the left is the natural carbon cycle with a balanced state, where we have yellow arrows showing the sources of atmospheric carbon. So from the respiration of mammals, including ourselves, decomposition of materials, and from smoke from fires. Those gather into the air and form the atmospheric carbon. Then we have sinks, which are the black arrows coming down, and that's where the carbon is uptake by plants, being forests, also goes into the water, and is also something that collects in the geologic layers, forming our carbon-rich minerals, our oils and gases. So on the right, we show the example of where greenhouse gas has increased. We've upset the balance because of the amount that we burn as fossil fuels, because of some of our practices like destroying wetlands, our industrial discharges, and obviously deforestation, which is causing more smoke and more carbon into the atmosphere, which creates an enhanced greenhouse gas impact. And the very small chart in the top right-hand corner, I don't expect anybody to be able to read it, but what that is showing is the red line called the Keeling's graph, which shows that after industrial revolution, the carbon dioxide greatly increases. Some refer to this diagram as the hockey stick diagram, but that is illustrating how greenhouse gases have been on the rise ever since. The other thing I'll mention is, as far as water and land heating and cooling, it's something that will come up later when we start talking about ice cover. So what is climate? Well, here's a couple of examples. One on the left is taken from the Building Science Corporation's map, which is basically looking at both temperature and moisture, and they use that to make decisions on building materials. And again, a very rough, maybe crude, but it's also very important when you start talking about furnace designs, air conditioning, that kind of thing. The graph on the diagram on the right is a more detailed one, just showing the United States, and it's from the International Code Council. And it's an example of how they actually use information like that for building codes. So for example, if you're constructing a house, if you're using drywall, putting a vapor barrier in between the drywall itself and the insulation is something quite common in the northern parts of US and certainly in Canada. That is not something that's wise in the southern part of the US just because of the amount of moisture and humidity, and that is something that would rot the studs, the 2x4s, and also the siding on the building. So there's an example of how climate is derived, the aspects of a building code and implementation of it. I like to quote David Phillips, our senior climatologist. He always talks about Canadians having the largest clothes closets given our range of 4 seasons and all the weather characteristics that we have to endure. So perhaps our building codes are a little more detailed than some of the other areas of North America. In Canada, we've got 11 climate zones or climate regions. And for those of you that are familiar with soils maps or forestry maps, there are a lot of similarities between these different zones and those different features because they are all interrelated. You'll note that Southern Ontario has its own separate climate, referred to here as the Great Lakes St. Lawrence lowlands. And it's probably safe to say that the reason we have that separate climate is because of the proximity right beside the Great Lakes. If you think of predominantly west winds and all that water, that is giving us the climate that we have in Southern Ontario. This is a graphic or a satellite image that I like to use. It shows a slightly different orientation of Southwest Ontario than what you normally see. The north arrow would be pointing to the right on this diagram, and it very much shows that Southern Ontario, Southwest specifically, is right in the middle of these large land masses that obviously influence climate and also influence our day-to-day weather. I'll point out just for georeferencing purposes that the area to the I guess top right of Lake Ontario, that gray mass is showing up as being Toronto. And the coastal center, again for georeferencing, I've just located where Goderich is by the white puffy cloud, which is showing over top of it. The reason I'm pointing out these gray mass areas because urbanization does have an impact, which is referred to as the urban heat island. And when we start talking about climate change, that is a real factor. The amount of pavement, the amount of hard surface actually has an impact on the local climate or on the local weather. This is something that really heats up in the area around those large masses of concrete. The other one that I'll point out is if you can picture where London would be, which is directly on top of, I guess in the middle of Lake Huron, Lake Erie, and Lake Huron, there's a gray area. And that is something that has historically been referred to as the thunderstorm capital of Canada because of its location in the middle of all these masses of water. So certainly the Great Lakes have an impact. Weather, on the other hand, this is the stuff that gets talked about at the local coffee shop in the mornings. This is the daily and the weekly differences with regards to weather, whether it's temperature, moisture, whether we're talking about snow or rain, and certainly wind. And it's the kind of thing that changes very rapidly, very frequently. Even tonight, for those people that are watching the weather, we've had a major storm roll through Sarnia. I believe there's power outages out. And certainly that is a weather phenomena that is what we categorize as a severe storm. They were talking about keeping people off the streets because of flooding. So this is an extreme weather event, which has ironically happened tonight as we're talking about climate change. These are just a couple of examples, these photos of what we certainly see in the Great Lakes, including Lake Huron, and what we're predicting to be warmer, wetter, and wilder in our immediate future. There's already considerable evidence that are suggesting that we're already experiencing these impacts. The challenge is that trends in meteorological readings are needed to confirm the changes are due to climate change. So trends take time, and that's what climate is based on. Therefore, you'll often hear meteorologists and climatologists say that what's happening is an indication of the weather patterns typical of what we expect to see with a changing climate, but they can't say specifically that this event, for example, the rainfall tonight, was caused by climate change. Now, I've mentioned a couple of times different rates of heating and cooling. These are examples on the left talking about wind patterns, a lake breeze. Part of the reason for the change in weather is the impact that climate change on some of the normal routines that Lake Huron and the rest of the Great Lakes have on our coastline. So the graph on the left illustrates that land masses heat up and cool down more quickly than the water bodies do. Therefore, differential heating and cooling along the coastline sets up what we refer to as a lake breeze during the day and an offshore breeze at night. And if you're somebody who sails, you'll know these winds as they're often what allows you in and out of the harbors and your reliance on them to power your vessel. The graphic or the image on the right shows that water bodies like Lake Huron also provide air moisture during the late fall and early winter when the lakes are still warm compared to the cold landmass, setting up a situation which we refer to as lake effect snow. These snow belt regions will only be enhanced by warmer air and water conditions that prevent ice cover from forming on the lakes and creating a shorter ice season, which has been the case in the past few years. For those people driving in Southern Ontario, you're used to that image on the left, which is the satellite image showing, or satellite radar showing radar from the Exeter station. If you can pick out the red dot in the center, that's the Exeter golf ball. If you've ever driven by it, that's what it looks like. And it's showing, in this case, the storm of December 2010, which was a 3-day streamer that sat over London, Ontario, which they termed Snowmageddon. It closed down hospitals, it closed down the university and Fanshawe College. So it was a major event, all because of snow squalls off the lake. Now, top right image is a frigid winter in 2014 when Lake Huron did almost freeze completely over. However, the bottom right graph, and again, I realize the numbers may be too small, but since 1973, they've been taking ice cover readings. And the yellow line is a rough approximation of the trend line, which shows that ice cover, all the Great Lakes, is slowly declining since 1973. And that is the expectation into the future as we have a warming climate and warmer moisture, more moisture. We will find that Great Lakes are not as ice covered as they have been. So the projections are for a wetter winter and drier summers. For example, as far as water temperature goes, Lake Superior, being the largest freshwater lake in the world, has increased surface water temperature by about 2 degrees over the last 30 years. And when you think about the massive amount of water in Lake Superior and such that lake eventually drains its way through the rest of the Great Lakes system, it's certainly an indication of what's to come. It basically feeds the rest of the Great Lakes. So warmer, wetter, and wilder is a term, I believe it was the region of Durham and their climate change action plan first coined. And basically these 6 bullets describe it. The Great Lakes Basin has warmed several degrees in the last decades. Temperature increases are consistent with global temperature increases. I believe the 17 hottest global average temperatures have been in the last 16 years. So certainly we are seeing the impacts of a changing climate. Heat waves will be more likely, especially the evening hours. We're quite frequently finding hot days and then cool nights. Heat waves will be such that the temperature at night does not cool down. And that is something that's worrisome, especially for those in perhaps high rises and in larger centers. The opportunity to have some relief next to the shoreline of the Great Lakes is there because we will have a slight sea breeze and land breeze, but again, heat waves will probably overtake the positive impact of those cooling effects. Precipitation will likely be less in snow and more in rain, so therefore more rainy winters, more opportunities for rain on snowpacks. And certainly more extreme and more frequent storms, and that's where the warmer, wetter, and wilder frame comes from. And I mentioned the urban heat island before, and the fact that Toronto and other urban cities, they will have a slightly higher temperature at those locations just because of the amount of pavement that is giving off that long wave radiation. So erosion is always a concern, and how is that going to play out with regards to our Lake Huron shoreline specifically and the Great Lakes in general? Well, certainly with a wilder climate and wilder weather, it means more wave action, resculpting the shoreline, like this image of a wave crashing illustrates. So waves interacting with the Lake Huron coast will create different impacts depending on the water levels and also on where you're located along the Lake Huron shoreline, what coastal type you're in. But before we dive into that too much further, it's often asked, we hear a lot about sea level rise. And the question is, will sea level rise impact the Great Lakes water levels? Well, the simple answer is no. Sea level rise is a huge global concern to all ocean coasts, and especially to marine islands. However, this phenomena of oceans and rising water levels is directly due to melting polar ice caps and mountain glaciers. So for example, the Greenland ice cap, which you can see in white on the left image, satellite image, and a feature like the Columbia ice fields in BC. These are features that feed other water courses that do not flow to the Great Lakes. So the Great Lakes are not fed by any of these sources from melting glacial ice or snow. Great Lakes are fed by the adjacent rivers and streams that flow into them. However, none of these Great Lake tributary waterways are in the mountainous watersheds where melting ice from glaciers are increasing their flow and adding more water. That would be the case, for example, Calgary and the Bow River that gets its headwaters from the Columbia ice field. That is something that will eventually change the flow of the river and probably already has. Therefore, the fluctuating Great Lakes water levels have nothing to do with sea level rise and climate change. The St. Lawrence River, which you might recall is the outlet for the Great Lakes, will experience some impacts, such as salt water moving further up the river from the Atlantic, and perhaps somewhat of a water level rise as well. However, those impacts are not anticipated to progress far enough upstream to reach the Great Lakes. So water levels. This is a graph that shows all the way from 1918 to 2013, and then I've added a circle just to show where 2019 is located. And predicting Great Lakes water levels has always ranged from being difficult to impossible. When you factor in climate change, that makes the issue even more challenging. What seems to be happening is that we're experiencing a shorter time frame between extreme water level periods. And that's the reason why I put on where 2019, where we are today, which is very close to the high water levels of 1986. The lowest water levels since 1918, when records were taken, is still considered 1964, although we did have a couple of months in 2013 where those monthly means dropped below the 1964. So again, just roughly speaking, 1930 was a period of high water level, generally 1964 being the lowest, 86 being the highest again, 2013 being very low. Now we're back up within 6 years of almost where we were in 1986. The normal range for Lake Huron is about 2 meters, as you can see from the graph here, 175.5 to 177.5 roughly. And the expectations are that the range will remain relatively the same, perhaps with some minor movement of the upper and lower limits. However, with a wetter, warmer, and wilder climate, we may see increases in the speed in which the extreme levels are felt, such as the one shown here, which is a six-year span. Now, with the coastal center, it's interesting because quite often we're dealing with multi-generational cottages, people that have been on the lake for years and years and years. And those people have that memory. They have that understanding of the highs and the lows from 1964 to 86 and perhaps where we are today. It's the people that don't have that knowledge that sometimes have difficulty understanding when we're looking at a shoreline property that this is all going to change. Things are going to change abruptly with water level and with storms. So this shortened time frame might actually help with regards to making sure people remember what happened in the low water levels, what happened in the higher water levels. So that's just a comment on the side with regards to how it may impact some of the work that we do. So looking at Lake Huron, which I'm sure everyone who's on the call recognizes, on the left-hand side, we've got the shape of Lake Huron, blue being the water, the white being the landmass with all our different villages and settlements. On the right is an image that you may not be that familiar with. It's as if we drained the water out of the lake. So all the colored area shows the depth of Lake Huron. All the gray area shows the actual water, the land surface itself. And what you'll see is Point Clark, which is located about halfway up the eastern shore of Lake Huron, right around this area here. From that area south, where red is shallow and blue is very deep, we have a fairly shallow shoreline all the way down from Point Clark, certainly around the Pinery Provincial Park area and all the way down to Sarnia. Over on the Michigan side, you can see Saginaw Bay and how shallow that is. So a very different shoreline compared to the area to the north of Point Clark, getting up around the Bruce Peninsula and all the way up to Tobermory, where it's much deeper, closer offshore. And that has an impact for water levels. Because if you're looking at a very shallow area like say the Pinery Grand Bend area, or even over here at Nottawasaga Bay, where we've got a very shallow offshore, a very minor change in water level is going to make a big horizontal distance difference with regards to where the water's edge is. So, you know, just a couple of centimeters will change where the water line is, how far you have to walk out on the beach before you actually get your feet wet. Whereas up here, where it's much deeper, it's more of a vertical. If you think of some of the cliffs around the Bruce Peninsula, water level change will not change the distance horizontally of where the shoreline is. It just means that you have to dive deeper or longer before you get into the water. So those different types of shorelines in the geographic locations that I pointed out will react differently to the water levels. The Coastal Center has done specific research in the area of Oliphant and also in Goderich to estimate the horizontal distance of water edge under different climate change scenarios and what the offshore impacts to infrastructure and even the impacts to commerce, knowing that Goderich is a deep water port from lower water levels as well as higher ones as well. We then have to translate those changes in water levels to the various coastal ecosystems. So this image is actually taken out of the Southern Georgian Bay Shoreline Stewardship Guide that the Coastal Center completed with our partners back in 2013. And this is Nottawasaga Bay, which I just pointed out on the lake depth chart, showing the different ecosystems that occur, whether they're the river mouth at Nottawasaga River or the sand dunes further to the north and tiny, cobble beaches further north again, the bluffs and the cliffs and the wetlands. These are all ecosystems that will react differently to different scenarios with regards to certainly water levels. And obviously that is tied to climate change. Hotter, warmer, and wilder will have impacts on wetlands and the ability for them to adjust. The other thing that I should mention is there's a concept called seasonal turnover of the water in Lake Huron, which is when the warmer surface water exchanges with the colder, deeper water. This happens sometime in the summer, which in turn redistributes organisms that are food sources for fish and other aquatic life. So this is a very important concept in the hydrology of the lake. So the timing of this turnover is expected to be altered by warmer waters, which will in turn impact aquatic life stages and life cycles. So we do know that this is something that we're starting to see already. I've already mentioned the erosive force of waves. So along our bluff ecosystems, where non-cohesive glacial till comprises the majority of our bluffs, extreme weather events predicted under a changing climate will increase the erosive nature of the storm waves, especially under the influence of higher water levels. So there's the wilder portion of the weather forecast. This will in turn result in substantially more sediment transport along shore in those unstable bluffs areas where transport already exists along the shoreline of sand, or in areas that are in transition from what we refer to as source areas, which both these images, these photographs would certainly be labeled as source areas where erosion is occurring, to sink areas where the deposition occurs, which is where we find our large beaches, such as Nottawasaga, Grand Band Dipperwash area, Sauble Beach. So when we talk about erosion, we talk about bluffs and their stability. This diagram shows what's generally referred to as the stable slope and the recession line. And certainly that is something that is important to consider, but what we also need to consider is the area below the water line, shown by the two red arrows here. Even with lower water levels, being a stormier condition, we will have erosion in the offshore. And that is something that will eventually make its way up to the stability of the slope. So it will impact, it may take 5 or 10 years, but that is something that even during lower water levels, when the water isn't necessarily right at lapping at the toe of the slope, you will find erosion happening in the offshore, which will eventually allow deeper waves to roll in and possibly even reach the toe of the bluff, even though water levels are much lower. So that is something that has occurred in the past. We've noticed it since the 1986 high lake levels when we had lower water levels, but it's something again to probably look at as an exaggeration with climate change. So I mentioned sediment movement. One of our ecosystem areas is a dynamic beach, and by nature of the term, obviously we've got a lot of movement of sand. And with more rapid change in water levels, like we've seen in the last 6 years, dynamic beaches will only become more dynamic, shifting and changing to the changing water levels and wave conditions brought by increased storms. The changes shown in these photos span almost 20 years, and the expectation is we'll see this type of change more rapidly. This won't take 20 years. This might be half that distance or half that time frame. These are two examples from 1986 during the high water levels and 2005 in southern Bruce County. A more recent example of movement of sand is actually shown in this photograph. I'm standing next to one of the beach areas in Pinery Provincial Park where the dune has been what's eroded or cliffed, as the term is. And basically it's the movement of all that sand taking from the reservoir of sand that the dune held and removing it offshore. And keep in mind, this is a length of shoreline about 13 kilometers long. So there's a massive amount of sand that's been moved offshore and transferred into sandbars, which will be ready to be washed back onto shore once the water levels recede and there's more aeolian or wind transport of that sand. And this is an illustration of that dynamic nature of the sand being available to be eroded away during high water levels and storms, and then rebuilding again once lower water levels and calmer waters are in existence. And this is certainly something that we expect to see more frequently and more rapidly with a changing climate. Another question is, how is this going to impact invasive species? While we certainly have experience with Phragmites shown in this photograph, Every time I show this photograph, people ask me, why are these people smiling? This is about 5-meter tall Phragmites, I believe, in the Port Burwell area. This is Frank Laternal, who is a qualified pesticide applicator and someone who is very well versed. The Coastal Center has done a lot of work with him on removal of Phragmites. And certainly Phragmites australis is the real name, the Latin name, commonly known just as the common reed. And it will need to adapt to a warmer climate and more rapid fluctuations in water levels. But we know that based on the existing experience, this invasive species seems to have no problem adapting to all these types of variations. So warmer air and water temperatures will most likely mean an increase in non-native species impacting our ecosystem by possibly replacing some native species while increasing other species such as pests and disease. Observations that have been made in one of the reports I mentioned at the beginning from the Environmental Law and Policy Center in a collection of climate change observations for the Great Lakes is that sport and bait fish populations have already been seen shifting their range northward. Some species up to 15 kilometers north in some instances. So warmer temperatures are probably going to benefit some species of invasive species that we already have, such as round goby. And the term species replacement will become more common, where we find perhaps walleye are not as prolific and other species are coming in and taking their place in a warmer climate or warmer water. So when we talk about actions, what can we do with regards to climate change? We commonly refer to climate change mitigation versus adaptation. And these two circles, Venn diagram, show that in the mitigation side of it, what we're trying to do there is have actions that will actually reduce the greenhouse emissions. So this is the type of actions that have energy conservation in mind. This is talking about reducing our fossil fuel use, using active transportation like walking and cycling more frequently than driving cars, anything that will reduce the greenhouse gas emissions. That's where transit use comes in, more fuel efficient or electric vehicles, and certainly the whole issue of air travel and the amount of greenhouse gases that are contributing to the atmosphere from that. On the adaptation side, that's where we're looking at actions, measures that will lessen the impact of these climate changes on ourselves and on our communities. And certainly we do know that the climate change train is already in motion. We know that we are going to have a warmer climate. It's just a question of how warm. And certainly adaptation is something that needs to be looked at by communities and certainly by governments. There are several actions that do both, and that's where the sweet spot in the middle, where the two circles overlap. So anything green with regards to tree canopy or green roofs, these not only protect us and reduce some of the resources needed to heat our homes or to provide air conditioning, but also they tend to absorb greenhouse gases and carbon dioxide specifically. So those are the actions that will reduce transportation, like using and buying local food. And so actions that do both. They're mitigating the carbon dioxide emissions. They're also helping us adapt to a more sustainable lifestyle. So when we talk about how those types of things, how they're implemented, it's good to look at examples. The one example I've got is for a medium-sized city. And this is actually taken from the City of London, which I know is not on the coast, but it's very close by, as we pointed out in the satellite image. It's the thunderstorm capital of Canada. And the graphic on the left, again, the numbers don't worry too much about. What I'm wanting you to take away is the personal vehicle use when it comes to greenhouse gas emissions, which is the diagram on the left. By far the largest greenhouse gas emission makes up about 50% of vehicle use and home energy sources are where the greenhouse gases are being emitted from. So even just minor changes in how we drive or what we drive, what type of vehicle, or how energy efficient our homes are will make a substantial difference with regards to the amount of greenhouse gases that are emitted. And if you can see the diagram, it trends all the way down into industrial and commercial buildings. They are much less, almost half of what our personal vehicles give off. Methane from landfills is another source. Civic buildings, so buildings that are housing our governments are something that is also being tracked and considered. And then aviation and rail freight are the last two on the scale. But again, the message here to take away is the top two are the largest, and they consist of about 50% of the total greenhouse gas emissions here in this example in London. Now, in the other graph or the other diagram on the right, talking about household impact, over 83% of household contribution of greenhouse gases comes again from vehicle gas, being 51%, and home heating, 32%. So even just looking at a household, significant amount of greenhouse gases that are coming from those houses are coming from your vehicle and your home heating. Water heating comes in next at a mere 9%. So individual actions will make a huge impact on greenhouse gas emissions if done collectively. And there's the key. We need to get more people talking about, more people realizing the impact, and more people that are actually taking action to make reductions in those areas. So how do we do that? Well, one way is to get governments to make it easier for us to make those decisions by providing incentives. And that is something that has been proven time and time again in all sorts of different venues and areas. So coming into the question of, okay, what are the actions? Well, we've already mentioned individual actions, personal lifestyle decisions, even the clothes that you're wearing, the amount of travel you do, what you're eating. Those are the types of decisions that you can make with regards to choices, where your food comes from, whether it's local, whether it's a 100-mile diet. Community actions, again, that's just something where if you're interested in helping out, get involved with your community, get involved with the community activists who are making a difference, getting the message out. Certainly there are things like carpooling and sharing solar energy. Those are aspects that are very much effective at a community level. And last but not least, obviously, vote. Be involved in your local government, your municipal, provincial, and federal governments, and choose those candidates and parties that best articulate wise actions for climate change. So on a personal level, I like quoting the sustainability coordinator from Simon Fraser University. I heard her recently quoted on a CBC podcast, and she was recommending the 24-24-24 Climate Action Pledge. So what will you pledge to do differently in the next 24 hours? Or in other words, the next couple of days. What will you pledge to do differently in 24 days? Or in other words, about a month. And lastly, what will you pledge to do differently to reduce greenhouse gas emissions in the next 24 months, or in other words, the next couple of years? So these pledges are illustrating actions for the short, medium, and longer term. And if you think about it, they could be very easy. In the next 24 hours, you could reduce, maybe have one less meat-based food choice. Have a fish instead of a steak. In the next 24 weeks, what will you do differently? Well, ironically, today was the announcement of the federal election coming up on October the, I think, 21st. So definitely there's an opportunity to get involved, get engaged, understand the different candidates and what their plans are for combating and adapting to climate change. And then the next 24 months, the next 2 years, what are the big ticket items that you might be considering purchasing, whether it's a new car, whether it's a new furnace, and give some thought to how that impacts greenhouse gases, as well as reducing the resource use, reducing the amount of money that you're spending on energy. I always like the quote from one of a retrofitter, a person that does home renovations, and he said the cheapest gas out there is the gas that you don't use to heat your home. And obviously he's talking about insulating your home better and making sure that it's draft proof. So what does this mean for the future? What's it look like looking ahead? Well, just a few more slides left, and then we'll open it up for questions. I probably should have said at the very beginning, if you have questions and you want to just type them in, we'll take a look at them and review them at the very end. So this is looking to the future. We should start with what's our existing situation. So this is information, a graph showing us who is drinking Lake Huron. 2.4 million people on both sides of the border. This is information from Source Water Protection, which was an inventory and safeguarding of drinking water. And it basically provides us with the data that we can illustrate that there are 28 drinking water treatment plants withdrawing from Lake Huron, 5 of them in Michigan and 23 in Ontario, quenching the thirst of 2.4 million people. Now, it's a little misleading. The 5 in Michigan services 80% of the population. So 80% is almost 2 million people, with the 23 in Ontario being much smaller facilities, and they are servicing 20% of the population, which is about 500,000. The 2 largest plants are the 2 biggest red dots, one at Fort Gratiot, just north of Sarnia in Michigan, and the other one at Grand Bend, or more accurately in Lambton Shores. And those provide 92% of the water to about 75% of the population, the basin population. So what will be the stresses on the infrastructure given climate change impacts? So warmer water, we know, will carry increased bacteria and pathogens. More inland erosion from the storms will carry not only sediment off of agricultural fields, but also contribute more soil erosion and nutrients, such as nitrogen and phosphorus, possibly creating more algae blooms. Increased storms and runoff from existing or from urban centers will put pressure on our wastewater and stormwater systems. So this is the existing scenario. What about an increase in population? So this is a little bit of a crystal balling, but if we are seeing growth in areas like Saugeen Shores and like Collingwood in the past decade, how will we balance growth with environmental sustainability if that growth continues in other areas as well along the shoreline? So there's some thought-provoking research that's being done. This was published in the Science Journal in June of 2017. This is of the US, and it shows the economic impact suggested by both climatologists and economists from climate change in the US. So very quickly, the red shows areas projected to be worse off economically, and the blue color shows areas that are projected to be better off economically under a changing climate. This certainly matches some of the areas presently experiencing the impacts of climate change, such as the Hurricane Dorian that swept up the East Coast from Florida on up. Certainly the forest fires in the California area also show up as well, but certainly the whole Gulf states show up as being an area that will be worse off economically. And if people's actions are currently part of the problem, stressing Lake Huron and the Great Lakes, it suggests that we may experience a population migration north towards those blue areas. And if that's the case, that is something that we need to start looking at into the future. What are the ways that we're putting effective policies in place, looking at proper stewardship now with the existing population, if we in fact are starting to see this as an area of growth? This impact map supports another interesting recent phenomena. Several Great Lakes US cities are coining the term and advertising themselves as climate sanctuary cities, where the negative impacts of climate change are comparatively less than in other states. For example, Florida, Texas, and those other Gulf states. So cities such as Duluth, Minnesota, and Buffalo, New York, are suggesting that their climate is better suited in a changed climate when compared to other US states and cities. It's interesting, it's quite a marketing turnaround when their weather and climate were historically described as disadvantages to populations. You know, the whole idea of who would ever want to live in Buffalo, for example. Now perhaps that situation may change as a realization of most extreme impacts of climate change, including economic impacts, are seen to occur in these other areas of the US and in the world. So from my perspective, the take-home message of this graphic is that the stresses that exist now on Lake Huron and our Great Lakes ecosystems could experience more pressures. Therefore, the time to act is now. These human-induced stressors, invasive species, imperviousness, shoreline hardening, water pollution from both agriculture and cities needs to be correctly assessed and wisely managed now to ensure that any future increased population will not further aggravate these fragile ecosystems. That provides even more impetus for us to have a clear understanding of the existing stresses that climate change presents now on Lake Huron, and to encourage individual action and wise decisions from all levels of government to safeguard our Lake Huron and the other Great Lakes. After all, this is our home, and Lake Huron deserves our continued attention. Wise stewardship actions now are more important now than ever. For those people that are interested in some of the items that I've been referencing, I've put this slide together just to show where they came from. As I mentioned at the beginning of the webinar, we will have all the webinars posted on our website. So this will be available to you shortly if you're interested in finding out more. And at this point in time, I will see if I have the technology to identify the questions. And I think we've got 3. Yeah, questions are the aerial map at the beginning. Why did Toronto show up as gray? Yeah, good question. The satellite image basically differentiates between those areas that are forested and those areas that are not forested. So the areas that have natural vegetation show up as green, whether they be forests or agricultural. And certainly the pavement is what is showing up as gray, or the built up area. The satellite image has been enhanced. Nepotis, I believe, is the organization that has the reference, and they have done a little bit of enhancement just to make sure that the Niagara Escarpment shows up, for example, in a fairly significant feature. So a little bit of adjustment has been made to it. The color itself, I don't know for a fact, but that is something that certainly could find out by contacting that group. Wind causes wave. Actual photo, the question, that one photo that have of a wave crashing, that is an actual photo. It was not Lake Huron. My understanding is that was a beach in Michigan, but it is such a captivating photograph showing the energy of the waves and showing the aspects of how movement of sand and water is certainly something that is extremely powerful on the Great Lakes, just because they're inland seas. They're big enough, they could be oceans, but they're not saltwater, and they're not tidal. And as we pointed out before, they are not impacted by sea level rise. So those are the differences. And the third question I've got here is the reason for downspout disconnection. Yeah, it's a very good point. Unfortunately, with climate change comes a lot of jargon, and downspout disconnect is one of those pieces that is very familiar in urban areas. And what that refers to is before, I think it was 1980, when the building code changed, people connected their eaves trough downspout directly into the ground and into sewers, so into the sanitary sewer system. And the sanitary sewer system is the one that gets treated. So not only is the wastewater from our sinks and toilets and showers going into that system, but also the roof water in those homes that have a downspout connected to it, which means that if we get more rain, it overwhelms the wastewater treatment plants. And that's why we have bypasses, and that's why we have problems in our larger urban centers, which have some of this older, I'll call it infrastructure. In this case, this is infrastructure related to the house. So disconnecting the downspout doesn't mean disconnecting it up at the top, where the eaves trough is. It means disconnecting it from the ground level, the ground surface, and putting it out onto the ground, or putting it into a rain garden, for example, and actually allowing the water to seep into the ground and use the water with plants, as opposed to putting it into a already stressed wastewater sewer system, which is going to be more stressed with climate change and more extreme weather. So those are the 3 questions, and I do appreciate those. Oh, I might have one more. Is there a concern for algae blooms on Lake Huron in the near future? Yeah, good question. We certainly see what's happening in Lake Erie. Lake Erie is our canary in the mine, so to speak, with regards to the impacts of over nutrification. And certainly What we've seen in the past is Lake Huron does suffer from algae blooms. We do find that along our shoreline beaches. Quite often they're related to historical phosphorus, which may be in the sediments, or it may be what's coming down some of our creeks and rivers, emptying into Lake Huron. I know in Goderich and I know in Sauble Beach, there have been many incidents, many years, where having to have equipment remove that material, the algae blooms that have been washing up on shore, has been a very costly expenditure. Are we thinking of that is going to be in our near future? A very good question. Certainly with lower water, it's probably going to be more acute than during higher water level periods. It really is a question of how well we treat the land which is draining into the lake. And going from the Lake Erie experience, we know that 80% of the nutrients, 80% of the phosphorus is coming off of agricultural land, primarily on the US side of Lake Erie, but certainly there's a contribution on the Canadian or on the Ontario side as well. Keep in mind, Lake Erie is extremely smaller compared to the massive amount of water in Lake Huron. Lake Erie is the shallowest of the Great Lakes. It is one that has all sorts of problems with regards to water quality historically, just because it is one that doesn't turn over its water as rapidly, or does turn over rapidly. Therefore, pollution can really take hold. But that is something that we will be wanting to monitor, and it is a reflection of how well we treat the land with regards to good stewardship of our agricultural lands, as well as making sure that we do have stormwater controls and wastewater systems that are working effectively. I think we've got time for one more question. Current high water levels are causing new owners and municipal leaders to permit armor stone and steel wall construction without understanding impacts on habitat and lake processes. How do we develop better long-term public policy on development along the lakeshore, setbacks, and shoreline structures using evidence, not fear? Very good question. Again, looking at the Lake Erie example, it's very telling to see the discussion going on with several strips of cottages, where we're now actually hearing the public officials talking about people should not be living there. People should not be rebuilding those buildings. Every time there's high water level and storm events, there is damage, there is threat to life. And that's the first time in my memory that we've heard that from public officials talking about there is a better way. We shouldn't rebuild in areas where perhaps we shouldn't have had buildings in the first place. So this current high water level is certainly creating that panic, I guess I'll call it, with regards to areas that are already threatened by erosion and by instability. And putting armor stone walls and steel wall construction is certainly an approach that has been used in the past. We've learned a lot more since 1986 on what works better and what has less impact on the environment. And certainly armor stone is something that has been used effectively in a lot of our public areas. If you spend time on the Goderich shoreline or even the Sarnia shoreline, you'll see lots of evidence of how the large armor stone has been used, not as a vertical wall, but as a stepped structure. And again, that is a hugely expensive approach, and it has to be warranted by a cost benefit. As far as the understanding the habitat and lake processes, I believe we're at a stage now where lake processes are being considered, and we're much better aware of those processes. However, the question will be, who are the regulators and who's policing that? We're in a situation right now where conservation authorities are being severely cut with their funding. And historically, they've been the ones that have been mandated to look at erosion and hazard management along the Great Lakes shoreline as well as the riverine. So a very good question with regards to how that will be policed and how well it will be managed into the future with those types of funding cuts. As far as developing a better long-term public policy and development along the shoreline, I guess I'll put a plug in for the work that the Coastal Center does, because we are in the process of a coastal action plan, which will talk about and provide direction on some of those issues with regards to the ecosystems and the impacts on those ecosystems with a varying degree of water levels and also with climate change. And definitely, again, I think we are better informed, and certainly our municipal councils have had experience with high water level in 1986, which hopefully they've learned some of the lessons with regards to tough decisions on development and making sure that we aren't putting people and structures at risk. So great question. Thank you very much for that. And I don't see any more questions. So on that note, I will thank you all for attending tonight's webinar. I'll mention a couple of things that if you're interested in volunteering for dune restoration in the Huron-Kinloss areas, contact the Coastal Center for details. Have I got my slide here? The Coastal Center's website is www.lakehuron.ca, and certainly contact us. There are links there for contacting us. The other thing I'll mention is there is a plant identification workshop in Point Clark, which is advertised on our Facebook page right now as well. So on that note, I will reveal that Aaron, Mitch, Kate, and I are not in the research vessel in the center of Lake Huron. We are, in fact, on the square in Goderich in our office and enjoying the evening without rain right now in Goderich. So hopefully you're safe at home or safe in your office. And again, thank you for joining us on the webinar. Keep an eye out on our website for the postings of the websites. And with that, I will say goodnight.